So let us learn today how to use logical operators in Python. What are the logical operators? How to use and how to write it in a program. Let us see. What are the logical operators? We have and we have a or, we have a not. And or are binary. Binary mean they require two operands, left hand side one and right hand side one. Whereas not is a unary. It requires only on the right hand side. Now what they will produce? They will produce either true or false. Same. True or false. Now, and when you will produce true, if both the sides are true, the result is true. Or any one of the side is true, the result is true. Not. The not is what? If it is true, not will convert to false. If it is false, not will convert to true. Let us see here in this case how it works for me. Okay. So I have written right now in this place my x is 10, my y is 3. I have written like this: x is greater than y and y is less than 10. If I write like this, what will happen? X is how much? 10. 10 is greater than 3 is what? True. Since it is true, it's going to solve the right hand side. And y is less than 10 is also what? True. 3 is less than 10 is true. True and true. Result is what? True. If this side is true, if this side is false, the result is going to be what? Result is going to be false. If this side is false, this side is true, the result is going to be false. If both the sides are false, the result is false. Whereas the OR operator works like this. The OR operator, if I put instead of this, if I put OR, if one side is true, the result is true. This side is true, therefore the result is true. This side is true, the result is true. This side is false, but this side is true. Result is what? True. But both the sides are false, the result is false. That means for OR, both the side needs to be what? False to become the false. Whereas in AND, both the side has to be what? True. Now the next is the NOT operator. If I say x is greater than y, 10 is greater than 3 is what? True. If I put not before, what will happen is in this case is the not will convert true to false. That's it. Okay. Let us see how it is working. So I've written like this. Okay. X is equal to 10. Y is equal to 3. I'm going to say print. Okay. X is greater than y and y is what? Less than 10. See what is the answer. I got true, right? Because both the sides are true, result is true. Now if I say here in this case x is less than y and I'm going to run the code, what is the answer? I'm going to get what? False. Okay. Now after this statement I'm going to print x and y. Print x and print what? Y. They remain the same. Okay. Like this. Yeah. Okay. Now look at this. I am going to say here right now print x is what? Greater than y. What I get what? In this case true. But if we put here not before, what is going to happen? It's going to convert it to false. Right. That's it. Okay. Now and require both the sides true or require what? Any one of the sides needs to be true. Okay. For or both of them has to be false to make the result as false. For and both of them have to be true so that the result becomes what? True. Remember that. Okay. Let us go to the next. So let's write a program. Okay. Let's write a program and understand this. So I'm going to, this is my question. So I'm going to put a multi-line comment. That means this code, this text will not be used by your compiler. Okay. Now this is a question. What is the question? Write a program to accept the coordinate point in x and y coordinate system and determine which quadrant the coordinate point lies. Which quadrant the coordinate points what lies. Okay. What is my input is going to be the x and y. Okay. Let's analyze the problem first. So what are the possibilities we are going to face? Okay. See, this is what I have. This is my xy coordinate. Okay. This is my first quadrant. This is my second quadrant. This is my third quadrant. This is my fourth quadrant. Correct? Now this is my x-axis. This is my y-axis. This is, we say minus y. This will become minus x, but it's the x-axis at the end. Right now. Okay. Now you say, see here in this place, x is positive and y is also positive. Here what? X is negative and y is what? Positive. Correct? And here is going to be what? Both are negative. X is negative, y is also what? Negative. And here is going to be what? X is what? Positive and y is going to be what? Negative. Correct? But there is a possibility in this place. The point can lie here also. See, if I put a point here, both are positive. If we put a point here, x is negative, y is what? Positive. If I put a point here what will happen here? X is negative, y is also what? Negative. Here if I put here, what has happened? My x is positive, y is what? Negative. But if I put a point here, x is positive, y is what? 0. If I put here means, what is the meaning of this? My y is what? 0, but my x is what? Positive. Correct? Understand? Yeah? Okay, so let's go to the how to write a code. Let us see here. So how to use my logical operator, let us see. My input is going to be the x and y. Okay, so I'm going to write my x and y. X is equal to int input. Okay, what I should write? Enter the x coordinate. Yeah. So now y is equal to int input, enter the y coordinate. Okay, now what I should do? If, so what I need to do, if you want to lie in the first quadrant, your x has to be positive and your y also has to be positive. See, both the condition has to be satisfied, so that it relies on the first quadrant. It is in first quadrant. I'm putting short form. Okay, else is not. I'm going to have one more else. If x is positive, if x is negative and less than 0, and y is what? Positive. That is a meaning, friend, it is what? In the second quadrant. If what I should do, if x is negative and y is also negative, then what I should write? Friend, it is a third quadrant. If what I should do, x is positive and what we said, and y is also what? Y is negative. It is a friend, it is going to be what? The fourth quadrant. Correct? Okay. If not, if else, if all the condition fails, that means what? In this case is one of them is what? 0. Right now, if x is 0, x is equal to 0, what I should do? Print it is going to be the x-axis. No, if not, it's going to be what? Else print it's going to be y-axis. Run the code. I'm going to enter the coordinate 5 and I put -5 and I got this output what is lying in the fourth quadrant. Okay, so if I put it right now, let's say if I put both, one is 0, other one is 5, it's going to be the x-axis. Correct? Yeah, understood the concept? Okay, why we use and? Or will be what? Any one of the condition needs to be satisfied. Remember that and is both the conditions should be satisfied, or is any one of the condition needs to be satisfied. Okay, let us see here. Go to the next problem. So we will solve our next problem. The next problem is we are going to find whether the given year is a leap year. Okay, what is the condition for a leap year? What is a leap year is? Okay, we all know it's okay. 2004 is a leap year. 2024 is a leap year, right? And what if it is 2000 is a leap year? Correct? Okay, so we all know as a child, we also know as a school children, we all studied any year that divisible by 4 is a leap year. Right now we always say every fourth year is a leap year, right? Okay, so it is not true. It is not what true. Okay, it's some true, some is false here. Okay, now let us see here in this case is when I will call a year is a leap year. As you rightly said, 2024 is a leap year, but 2025 is not a leap year because it is not divisible by 4. Okay, 2000 is a leap year. Okay, 2004 is a leap year. 2005 is not a leap year because not divisible. Okay, now sir, now let's see in this case is to 1996 is a leap year. Okay, 1900 is divisible by 4 but is not a leap year. Not a leap year. So our challenge comes here. Okay, you have a 2000, 2100 is not a leap year, but 2104 is a leap year. Oh, there is a challenge is coming when a year is divisible by 100. Okay, we all say every year has a 365 days. No, actually every year has a 365.24 days. So what we do in this case is we add the 0.24 at the every fourth year and we make 366. But if you add 0.24, if you add 0.24 four times, it only becomes 0.96, but we converted into 1. Okay, now 366 we made it, right? That means we are running shortage of 0.04. This 0.04 is being compensated at every 100. That means any year that ends with two zeros is not a leap year except fourth hundreds. Which are the fourth hundred? 2000 is a fourth hundred and 1600 is a fourth hundred, but 1700, 1800, 1900 is not the fourth hundred. That means every fourth hundred is a leap year, other hundreds are not leap year. That means this rule is applicable only for any year that divisible by 100. But otherwise same, it's every year divisible by 4 is a leap year, except the year that divisible by 100. Therefore, if you write down clearly, any year that divisible by 4 is a leap year, if and only if the year must not be divisible by 100. Must not be divisible by 100 means it should not be divisible by 100. Okay, if you want to use divisible by 4 condition, it should not be divisible by 100. Any year that divisible by 100 must be divisible by 400. In this case, how do you know divisible by 400? The remainder will be what? 0. Remainder would be 0. In this case, I'll call the year as a leap year. Okay, let's see how to write a code. What we said? If the year divisible by 4, how do you know divisible by 4? When I divide by 4, the remainder should be 0. Remainder should be 0. If the remainder is 0, it's not enough. You need to check. What you should check? Because that this condition cannot be applied for the year divisible by 100. Therefore, x modulus 100 should not be equal to 0. If both the conditions satisfied, it is a leap year, right? 2004 will satisfy this condition because when I enter 2004, 2004 modulus 4 is 0. 0 is equal to 0 is true, and 2004 modulus 100 is how much it is what? 4, which is not equal to 0. True, both are true, therefore it's a leap year, right? Otherwise, or is what? If the year is divisible by 100, it should be divisible by 400. In this case, I will use what? Print. Here two conditions are there right now. Therefore, I put, for you to understand better, I am putting a bracket. This is one condition, this is another condition. So I'm going to say print. What I want to print? I'm going to say x is a leap year. Else print x is not a leap year. Correct? Run the code. I'm entering a year. I enter a year is 2005. It is not a leap year. I'm going to run the code. Enter 2004 is a leap year. I'm going to enter 2000. It's a leap year. I'm going to enter 1900. It is not a leap year. Now, sir, in this two condition, one condition is not required. Why? Because any year that divisible by 400 is must be divisible by 100. It's an obvious rule. Therefore, this you can knock it out. This condition you can what? Knock it out. 2004, yes. 2000, yes. And 1900, no. Okay. Okay, so now one more thing I want to tell you. Okay, is the comparison need not be done with the numbers here. You can do with the strings also. Okay, I forgot to tell in the previous this one. Okay, let's say x is equal to, let's say hello. Okay, I can write like this: print x is equal to hello. It will give you true. Okay, remember that if I put here in this place, this is going to give me what, false. Yeah, it can be used with a comparison. Equal to, only equal to you can use. Okay, not greater than, less. Equal to can be used. Okay, so if you say like this, what's happening, x is greater than this. Okay, if I say here x is hello, see, I'm putting hello, I'm put wo, see, true. But if I say here in this case, this, what it give you, what, false. In this case, what happens, it compares character by character. H and H is equal, E and L. Now, but here what happens, here O is missing, here O is there right now. That's the reason it gave you what, this. Okay, let's say in this case is what happens if I put here in this place what a greater or lesser, let us say. Okay, I put HE, and see here I put like this. True. Why true? Because it compares H with H is equal. E with E, the ASCII value of small e is greater than what? The ASCII value of capital E. Therefore, even though the number of characters are more in hello, but the second character, what in this case is what? The ASCII value will become greater. The Unicode become greater. Therefore, it directly give you what, greater. Therefore, rest of the characters never compared. Even if you put here in this case HEI, still who is going to be greater is what? HEI, because E is greater. Okay, got it? Now the comparison happens character by character. Now whichever the first contradicting character whose ASCII value is going to compare, whoever is greater, it returns true or false. It returns what, true or false, here it returns. Okay, keep this in mind.